Another special triangle we end up seeing is called a 3-4-5 triangle, and this one doesn't specify the angles. Instead, it specifies the side lengths. This is if this leg is a distance of 3, a length of 3. This one is a length of 4. Then this one ends up being exactly a length of 5. So the side lengths come out as exact numbers, as really nice numbers, but then unfortunately the angles don't end up being too incredibly nice. This one ends up being approximately a 53-degree angle, and this one's approximately a 37. Not exact, but approximate. So 3-4-5 right triangle is really handy. It's actually one that I've seen used a number of times in construction. If you were to take a, let's say, a rope or a tape measure or something like that, and measure out 3 inches in this way, or you could say 3 feet, or any multiple of 3 feet. You could say measure, I don't know, 9 feet out in this direction, and then so this is 3 times 3. If I was to multiply this one by 3, I would get 12 feet in this direction, or 4 inches in this example. And then make sure that the distance between where these lie, so this distance up here, if that was 15 feet, of course this is 3 inches, 4 inches, and 5 inches, but you could, like I said, scale this up, multiply all the numbers by 3, I get 9, 12, and 15 instead of 3, 4, 5. This gives you a nice way of being able to construct an angle. This is called constructing the angle, such that this line and this line, you can be certain are really close to the angle between them is really close to a 90-degree angle. And this is especially important when you're dealing with something on the large scale, because there's no way you're going to have even a carpenter's square is nowhere near big enough to be able to tell you if you have a 90-degree angle on your building, if that's close. So let's say if you're on the scale of a building, you could even do something like, I don't know, 30 feet in this direction, and then 40 feet in this direction, and as long as you make sure that it's 50 feet between those, then you would actually be really, that would be really close to a 90-degree angle here. That'd be a very accurate measurement, without needing to use a reference angle to begin with. That's one of the really nice things about it. Alright, if we wanted to find the measure of the missing side of this particular triangle, I'm noticing that if this was obviously I'm talking about 3-4-5 right triangle, so I see it right away. This is 3 times 2. This one's 5 times 2. So this one is going to end up being 4 times 2, which is 8. But of course, if you don't happen to see that, you could use the Pythagorean theorem. You could say this squared plus that squared is equal to that squared. A squared plus 6 squared equals 10 squared. So a squared plus 36 equals 100. Subtract 36 from both sides, we get a squared equals 64. And that means that a must be 8, because I took the square root of 64. So that distance would have to be 8.